Welcome to our channel Euclid Mathematics. We have started lecture series on CSIR, NET, SET, GATE and other competitive exam too. So within that I already explained plenty of the videos on my channel. If you wanted to see, you may check my playlist. So here in my today's video, I'm gonna explain to you all one of the previous year question from GATE Mathematics. Question is conceptual base and little calculation we needed there. Okay, now let's start our today's question example. First of all, I'm gonna explain to you all the question and then we'll move for the detailed understanding of the solution. So here we have question. We given compute the matrix. Okay, we have to find out the matrix here, which is matrix A given I9 minus 2 U transpose U with U which is equal to 1 by 3 and all are the given 1 1 1 1 1 1 1 1 1. Okay, which is 9 columns and 1 row. That means 1 by 9 matrix. Okay, so 1 by 3 multiplied by 1 by 9 matrix. Okay, again I9 means here we have given 9 by 9 identity matrix. U transpose is a transpose of U given. Okay, that we have to build U transpose and U from this one. Okay, and next part of the question is, and further part of question, if lambda and mu are distinct eigenvalue of A, then we have to find out a modulus of a lambda minus mu. Okay, the eigenvalue from lambda minus eigenvalue from mu. Okay, then we have to find out which is the correct here. Okay, because this is the this is not a multiple selective or we don't have any option here. We have to just fill in the gap. It is like this one. Okay, so let's get started our today's solution. I will explain to you all a detailed solution of our question. So here in our question, we have to find out the matrix A. Okay, so we want the matrix A and the value for matrix which is given here I9 identity 9 by 9 matrix minus, okay, identity 9 by 9 matrix minus 2 times U transpose into U. Okay, so 2 times U transpose into U. So identity 9 by 9 matrix is easier, that all diagonal entries are 1, other remaining 0. This is identity 9 by 9 matrix. U transpose into U. So we know that U we have here. Just need to find out the U transpose into U. Then you will get the value for A. Find out the distinct eigenvalue of A and subtract them. We will get the required answer. Okay. So U which is equal to 1 by 3 under bracket 9 times 1. Okay, so this is the 1 row and 9 column. Okay, U is given 1 by 3 into this way. Okay, so how can we write U transpose? Take rows into the column and column into the row. Okay, so U transpose, it is coming 1 by 3. Okay, 1 3. Okay, this is the matrix. Okay, this is the 9 by 1 matrix now. Okay, so U and U transpose I got it here. Okay, so what do we want? We want the 2 times U transpose into U. Okay, so find out U transpose multiplied by U. Okay, then multiply these two matrices here, this one with the this one. Okay, so it is the multiplication of 1 by 3 into 1 by 3 which is 1 by 9 U transpose into U. This is the multiplication of U transpose into U, and then 1 by 3 multiplied by 1 by 3 which is 1 by 9. Okay, then we will get the 1 9 row. So what we have? U transpose into U, that means 9 by 1 into 1 by 9. So we'll get the 9 by 9 matrix, and if you multiply these two matrix, this is row vector and this is column vector, you will get the 1 by 1 1 1 up to 1 1 1 up to 1. Okay, up to 1. So you have to multiply. This one is easier. Okay, I'm not gonna explain here. So this one is easier to find out their multiplication. So I got the matrix U transpose into U, their multiplication, which is 1 by 9, and this 9 by 9 matrix, which all entries are 1. Okay, if now this is the U transpose into U. Okay, and we have to multiply 2 times U transpose into U and take it out from the I9. Okay, so 2 times U transpose into U, that means 2 by 9, and this matrix over here. Now let's find out the eigenvalue for U transpose into U. Okay, then we multiply 2 after of this. Okay, so to multiply 2 first and then apply eigenvalue it is similar as to find out the eigenvalue and then multiply 2. Okay, so here if we multiply 1 by 9 under brackets, 1 by 9, 1 by 9, 9 times 1 by 9. Okay, then that means we have 9 times 1 by 9 here in this row. In this column also 9 times 1 by 9. Okay, so if we see sum of all the entries of our rows or column, we get the 1. Add 1 by 9 9 times, we'll get the 1. Okay, or column we get the 1. So here we can see and one more result about eigenvalue for matrix. So if the sum of all entries of our matrix are similar, then we say that this is the one of the eigenvalue from our matrix. Okay, so I got the lambda which is equal to 1, which is the first eigenvalue from our matrix. Okay, lambda 1 is 1. So which is a 9 by 9 matrix, surely we'll get the 9 eigenvalues. Now what about for remaining eigenvalues? Because to find out, compute the eigenvalue from 9 by 9 matrix, it is quite a bit time taking, that we cannot do it easily. But if we apply some standard result from matrix, that you will get the easy answer. Okay, so here I got the first eigenvalue is 1, which is from our 9 by 9 matrix. One more result is there. If all entries are similar for our matrix, all entries are similar from our matrix, then we say that nth eigenvalue is a non-zero, but n minus 1 eigenvalue which is equal to 0. Okay, so what is the result? It says that if all the entries from our matrix is similar or same rows, same, all rows are same, then we write n minus 1 eigenvalue 0. All the n minus 1 eigenvalues are 0, and nth eigenvalue which is a non-zero. So n minus 1 means 9 minus 1, 9 minus 1. Okay, 9, n means it is a row column what we have here. Okay, so 9 minus 1 eigenvalue are 0. That means 8 eigenvalue, 8 lambdas are 0. That means we have 8 eigenvalue which is a 0 and 1 eigenvalue which is a non-zero. Okay, or you may go for the reduction of a matrix by using row transformation, column transformation, then you will get the required answer. Okay, so that is the other way to find out the answer also. Okay, so you can see it here. I got the only one eigenvalue 1 and remaining eigenvalues are 0. This is a 9 times 0. Okay, 8 times 0 and one eigenvalue 1. Okay, so we want the eigenvalue for 2 into u transpose of u. Okay, that means 2 multiplied by u transpose of u eigenvalue. So I got the lambda for u transpose into u, 2 into u transpose into u, which is a 2, and remaining all are 0. Okay, so this is the lambda for u transpose into u, 2 times u transpose into u. Okay, now lambda for I9. Okay, I want the eigenvalue for identity matrix of a 9 by 9. So as we can see, identity matrix of a 2 by 2. For example, let me explain eigenvalue for identity matrix of a 2 by 2, which is 1 and 1. So n by n matrix eigenvalue, it is a 2 by 2. If it is n by n is there, then we write 1 multiplied by 1 multiplied by 1, n times 1. Okay, so I9 means we have eigenvalue 1 multiplied by 1 multiplied by 1 till 9 times. Okay, this is a 9 times eigenvalue. Okay, so what we want the eigenvalue for a. Okay, that means eigenvalue for a means the eigenvalue for a which is equal to eigenvalue for I9 minus eigenvalue for 2 times u into u transpose. Okay, so there are other options for finding the eigenvalues that you may apply these ones here. It is not that difficult to find out the eigenvalues. Okay, but as I felt that sometimes we have to apply short tricks, some result that can give us very easily answers. Okay, so that one I did here. So I want the subtraction from the eigenvalue of a. That means I wanted to find out first of all the eigenvalue of a, means the eigenvalue for identity matrix of 9 9 by 9 minus the eigenvalue for 2 times u transpose into u. Okay, then subtract these two eigenvalues, you will get the eigenvalue for a. Okay, so you have to subtract I9 minus 2 times u transpose into u. Okay, that means 1 minus 2 will get the minus 1. Okay, 1 minus 2. So lambda for 2 times, so I9 minus 2 times U transpose into U, okay? To I9 minus 2 times U transpose into U. So 1 minus 2, which is minus 1, 1 minus 0, 1, and all are 1 minus 0, 1 minus 0, all are 1, okay? That means I got the eigenvalue for I9 minus 2 times U transpose into U, which is one eigenvalue is negative and another all eigenvalue is only 1, okay? So that means I can say easily here I got the first eigenvalue lambda 1, which is a negative 1, and the second eigenvalue which is a positive 1, okay? So don't, only those two eigenvalues I found it here. Because why lambda 2 is 1 here? Because all 9 eigenvalues are similar that you may take at once only, okay? So all eigenvalues 1 and only one eigenvalue negative 1. So in our question we have given what is the subtraction for these two eigenvalues, okay? Lambda minus mu, okay? Lambda and mu distinct eigenvalue for A, and these only two distinct I have here. Lambda is 1 and minus mu is a minus 1, okay? So 1 minus minus 1, so 1 plus 1, which is equal to 2, okay? This is a required answer from our question. I don't think so it's anything difficult, that we have to apply some basic concept from linear algebra that you will get the easy solution, okay? So I hope you all have understood this solution. Nothing is difficult here. For your reference, you may see my solution over here, that I solved it in other way, that might be my explanation is different than my solution. So but the answer are correct, okay? Don't get confused, because we may select any type of the counter example, or we may go through this in other way of explanation, okay? So here it is the complete solution. You may see, okay, this is the required answer, which is a 2, okay? This is the question from GATE exam, that very much easy questions are there, okay? But we need to understand how can we solve these questions, okay? So I hope you all have understood my today's solution. It is completely based on the eigenvalue for row vector and column vectors, okay? So thank you everyone. Thank you for my today's lecture.